Whoa!
I heard you fall. Let me help you. The reason you fell is similar to this problem in the book. In this problem, a platform assembly has a weight of 250 pounds and a center of gravity at G1. If it is intended to support a maximum load of 400 pounds placed at G2, determine the smallest counterweight, W, that should be placed 1 foot to the right of B in order to prevent the platform from tipping over. Here we have a free body diagram drawn, labeled with all the distances in between the points. We want W to be the minimum weight needed to prevent the structure from tipping over. When the structure is just prevented from tipping over, the wheel at B will barely be touching the ground, giving us a By force of 0 pounds. We wanted to eliminate the unknown variable Cy, so we decided to take the moments about C in taking counterclockwise as the positive direction. So here we have 0 equals W times 7 feet plus G1 times 1 feet minus G2 times 2 feet. Then we plugged in the values for G1 and G2. In this step, we brought the W to the other side of the equation. In this step, we multiplied the 400 by 2 and multiplied both sides of the equation by -1. Then divided by 7 feet, we get the final answer of 78.57 pounds. This answer is the minimum counterweight W that should be used in order to prevent the platform from tipping over.
I think I see another way of doing this. I think that we can use two equations. One moment equation about B using W, G1, Cy, and G2, and the second equation being the summation of forces of the y direction using all of the y forces in the structure. First, you take the moment equation and solve for Cy in terms of W. To do this, you need to get Cy over on the left side of the equation, isolating it from the other variables. Next, you need to divide both sides by -8 to get Cy by itself, with no coefficient in front of it. This gives us a value of Cy equaling W over 8 plus 218.75 plus 500 pounds. Plug this value in to the Cy variable in the summation of forces equation. This equation equals 0, and by plugging in that Cy value, we can then solve for the W variable. By bringing the W variable and its coefficient in front of it to the left side of the equation, we can get W by itself.
Oh, you're recording?
Yeah, we can cut it.
Okay. Although we got the same answer, my way was much quicker and more efficient. Therefore, my method should be used, not yours, idiot.
Oh, so I need a good counterbalance, like this backpack.
Exactly.
Now I won't fall over.